Welcome to another unit in this Excel course. This time I'm going to talk about how we can calculate different types of averages. Well, here I already prepared a data set. Well, the easiest way to calculate an average, you might have guessed, is a function called average. Could work around this, for example, with summing this up, dividing by the number of observations. But, well, the easiest way is usually using this average function. So if I use this, I get here my average of all those entries. As you can also see, well, I could extend the same stuff here to A, including all the text inputs here as well. I would still get the same result. Well, why? Because obviously I cannot add text. I cannot statistically evaluate text. If for some reason you have the idea that you want to consider text inputs also as numbers, being 0 here, you could change the average to average A. Then this would go down because I would have a lot of zeros here. In my opinion, that was rather bias your results, so I would always avoid the average in this context. However, more interestingly in this context, I'll go back to this, is a different function we have with the average. That's the average if and average ifs. We already talked about a similar thing when we talked about sums and counts. So we can do the same thing here. I can go with if, and then I can add, besides the range, some kind of criterion. So for example here, only do this for those entries which are smaller than 5. So basically only do this for those students who actually passed. I'm doing this, I'm getting a slightly different average. Just for comparison, that's the original average we have here. That's 2.73 and now we have 2.53. So that's by excluding all those guys who did not pass. It's easily done with an average if. Again, if I have only one condition, I can use the average if. And back here I have the range, so what I want to check, to which the criterion, the condition should apply. And I have here, not necessarily required, an average range where the average should be calculated from. So I could go, for example, here, again, do the average only for students with a specific name. And then you would only calculate here. Take a look. Is this the specific name? And here, that's then the average range. In B, take the corresponding scores and calculate their average. Okay, so we can do conditional averages, we can do averages, but this is still what we would call the arithmetic mean. That's also an additional aspect to mention here. We can calculate the mean via this average function, but there is no specific mean function for the arithmetic mean in Excel. So that's actually the same thing. Okay, so much for the average, the arithmetic average. But what if I were to have to calculate a different type of average? What do I mean by different type of average? Well, we additionally might have a weighted arithmetic mean, we might have a harmonic mean, or a geometric mean. Well, a weighted mean is, in my opinion, the easiest way to go. So imagine I have, let's say here, or let's write this below each other, 4 different numbers, and I have different weights. So let's note the weights here. They could add up to 1, not necessarily have to. Here I will just try to keep it this way. So in this case, they will all add up to 1. And then if I just want to calculate the weighted mean, what I can do is simply use this formula sum product, select the first range, semicolon, select the second range, and I will get the weighted mean. Okay, in this context I said, well, we could do this with weights which do not add up to 1. Yes, you could, but then you also had to divide this by the sum of all the weights. So we could go here, do the sum thing of all the weights, and then we're to add here dividing by the sum. Okay, in this case, if I already have one, it suffices if I only use the sum product. It's slightly roundabout way, but it still gets the job done, and I get my weighted average or my weighted mean. If on the other hand, for example, I have let's call this stock returns or interest rates or stuff like this, so whatever is changing at some point. Let's say I have here 0.2, 0.3, minus 0.1 and 0.05. Want to get the average of these, let's simplify this, growth rates. So growth rates could be stock returns, could be interest rates, could be whatever signifies change. So let's call them growth rates for simplification. And want to have the average of them. Usually it's a good approach to go with the geometric mean. The geometric mean, if I just start typing this in, I already see I have geomean, which is the geometric mean. So here I only need to input my data. And now I see the problem with this. The geometric mean has one problem. It's basically summing up, multiplying all those values up and taking the corresponding root out of this. So if you think back to your math class, you might come up with the solution to our problem here. Because as we have a negative value here, the result will be negative, so we cannot apply any kind of root to this, especially no root nor even numbered root, which we would do with 4 observations. So what we do in normal math classes where we are faced with this problem, we're not calculating the geometric mean of these growth rates, but we first calculate the so-called growth factors, which are just 1 plus the growth rate. Then we calculate the geometric mean of these growth factors and then go minus 1. We do this here. Now this works perfectly because all of these growth factors are positive. So here we see geometric mean is only possible for positive values. Okay, so this was the geometric mean, so there's only one thing left. That's usually for if I use relations or changes per something. That's the harmonic mean. Here I'm just going to do this with the marks as well. Not really the best way to apply it to data, but just so you can see. This is just, as with the geometric mean, it's the har mean. So the harmonic mean. Again, as it says here, harmonic mean of a data set of positive numbers. So again, we have to assure, similar to what we did here, that our numbers are all positive. Well, in this data set they are. So I would get here a harmonic mean of 2.3. As I said, usually it's not applied to absolute data, but more or less to something like acceleration or something like this. So, well, basically, we're done with the different types of means. There are the normal mean as we know it, the normal mean as we know it, the conditional mean. We talked about how we can construct a roundabout way with the sum product to getting a weighted average or weighted mean. We talked about how we can get our geometric mean, what we need to consider when we calculate the geometric mean, that we take not the pure growth rates, but the growth factors, and the harmonic mean. And well, that's all the means we're going to consider in the course of this unit. So I hope you enjoyed listening to this part, and if you want to see additional parts, feel free to visit the rest of the course or have a look at the corresponding playlist. I say goodbye and see you next time.